I'd like to propose you the research result of uh, neural network modeling for student competency development presented by Volodymyr Sokolov and prepared for international workshop of computer modeling and intelligence system. This research was um, prepared in Presgrichenko Metropolitan Kiev University. The main objective of the paper is to develop and validate a unified neurostructural modeling framework, a constructive generalization of feed-forward neural networks that provides improved training stability and convergence compared to classical backpropagation. In our previous works, we researched the neural networks and also the educational aspects of, and in this paper, we tried to compare these two, match these two different vectors in one. The problem formation. Due to the complexity of objects and phenomena of practical interest, neurostructural modeling methods that develop and generalize neural network methods to gain are gaining the greatest priority. That they can be used to solve a wide range of tasks in all fields of activity, including analytical tasks of predicating situations and managing the development of modeled objects. In this slide, you can see the subclasses of neural networks models. In the center, you can see the neural structural models, which consist classical neural network models, also fuzzy models, and different breed models such as adaptive neural fuzzy inference model. Uh, Also, the algorithm of neural structural model contains different cycles in which we trying to choose the different models for different purpose. At the initial stage, the type of neural network models is chosen, which determines the specifics of the connections in the neurostructural models and restrictions on the choice of activation functions. To ensure the monotonicity of the model omega construction, the set must contain a single activation function sigma from net. When expanding the structure to maintain monotonicity, they reduce the training error. It is necessary to use a special method of setting some adding bases. In the schema, you can see the structure of the information analytical systems in which both analysts and database developer works with the same data, but they have the different interfaces, and the database developer prepared the data for analysts, but analysts can choose the different types of neurostructural model systems in which this data will be um, which data these systems will be teached. And after that, the results will be exported in different systems or in standard files like XML or CVS. Also, uh, for different models, we can use different databases, but the source labeled data also prepared in one source. Also, you can use the different layer of this data with filters or without filters when you didn't need all the data for learning your model. The results. Other challenging and important tasks of using neural networks modeling in analytical data processing is a um, synthesis of optimal control of dynamic system whose model has a form y from t, and the formula you can see on the screen. I'll let u from t be the vector of control influence, which is a subvector of x from t. And let's consider the functionality j uh, with the formula you also can see on this screen. In the result, we propose not only the model, but also software for collecting the data, labeling it, and choosing different models for different purpose. And you can see the reports will be prepared in different types of data. Raw data showing on the display, in the files of different formats, and so on. Discussion. Thus, a narrow structural approach to modeling complex systems based on a unified view of the linear and non-linear structure takes into account ways during model construction, training, and application is investigated. This methodology involves the use of neural networks as a key tool for analyzing and modeling complex systems. In addition, effective algorithms aimed at solving modeling problems have been developed, and a set of software for data analysis based on neurostructural models have been created. The use of this approach can contribute to the formation of competencies of higher education students in the field of neural network modeling and machine learning, expanding their knowledge and skills in this area. Conclusions. The study developed numerical method for training neural networks and optimizing the controls in analytical problems. The research created programs for data modeling analysis to help students develop neural networks modeling skills. Results shows that machine learning and neural networks improve competency formation through efficient modeling and optimization training algorithms. The study confirms the method's potential for solving complex problems in education and other fields, emphasizing their values in higher education. The future result, the future work um, focused on the integration of neural network modeling with real-time adaptive learning systems to enhance personalized education and competency development in higher education. Thank you for your attention.